Good morning, everyone. So it's great to be here today, to be back. Let's see, why don't I do this? I'll stand here. I'll just talk from this. It's great to be back here. It was fun to be up in the city last year. Actually, I was looking for the address of the hotel, and I was like, oh, it's in San Francisco, but it's close. So I'm going to tell you a little bit about Joby today. For many of you have heard of us, many of you know what we're doing. But really, I think it's important to kind of look back and kind of realize why many of us are here and talking about what is this upcoming revolution in aerospace and aviation in particular that the latest technologies being applied into this space allow. And then what are the products, maybe more specifically, and how do we think about product development to actually make this real? Because you can develop all kinds of technologies, but it's not until you turn it into a product that you actually make it something that is real, that has the scale, and that starts to actually be able to change, kind of self-perpetuate in a way, right? And change the world, which is what Silicon Valley does. So, like I said, Eric Allison, Chief Product Officer at Joby Aviation, been in the eVTOL space for a long time. And I think that as I reflect back, I often like to start from the beginning. What is the reason? What is the foundational thing? Why many people in this area worked to start this new type of company? And I think that the reason really comes down to this. So this is, we're somewhere in here in this map. I live about here. A few years ago, I was running Uber Elevate, which did a lot of pioneering work in this whole space about trying to build the story, tell the use case, create the market for a certain type of revolutionary type of aviation. The Uber offices were up here, and every day I would drive this 37-mile trip that took me something like an hour and a half. Some days it was a little bit less, some days it was a little bit more. And then, of course, I had to go home every day. Maybe not every day, because I did pull a few all-nighters. So, but this is really kind of the foundational thing, that the experience of so many of us on a day-to-day basis, in the commuting that we do, even post-pandemic, especially honestly now, traffic here on 101, right alongside where this complex is, has gotten to be just like it was in 2019 prior to the pandemic, as more and more people come back to the office, as waves of commuting happen and on our daily lives, we deal with congestion, we deal with wasting time. We know that the costs are high. These are 2019 numbers. This is like the number of 360 million wasted hours per year in San Francisco alone in 2019. Maybe it's a little bit better right now because San Francisco itself hasn't fully come back from the pandemic. But certainly globally, this is the top 10 or 15 cities in the US, 4.6 billion hours per year wasted. This is a real thing. People are wasting time. This is a cost to the economy, and it's actually not solvable. I mean, there's been construction projects on 101, again, right here, pretty much for the 15 years I've been working in the eVTOL space, adding lanes, and I suspect that this is probably a low number for when in a congested, highly built-up area like California or like Silicon Valley, you're talking about adding more and more capacity, which of course is a diminishing return because it doesn't actually add all the capacity of another lane because of the way surface transportation networks work. And of course, the ongoing issue of what is the global contribution of emissions of the transportation industry. Something like 29% of global emissions. And so we definitely need to keep this top of mind as an aviation industry, how we fit into that global picture of what is the progress toward a more sustainable future. But yet, despite all that, it's still almost inconceivable that we would not have cars and surface transportation woven into the daily fabric of life that we have. But if you take a step back, this is New York in the 20s. And on the left, these are only a couple of years apart in the picture. On the left, you could probably, if you took the time, find the car that's in that photo. And on the right, you might be able to find the horse that's in that photo. And it's an example of a cascade that happened very rapidly, a change from one reality to another reality. And so I think that we have an opportunity as we define new revolutions in aviation to think of a time when this actually would be pretty normal to think about. Obviously, it's the ChatGPT picture, but when it's not like that flying cars are a crazy thing that you might not ever see, but that it's actually something that people could be using on a daily basis to do the types of movement around their cities that they could do. That's the vision. That's what so many of the companies in this space were created to try to bring to the world, and that's what Joby is pretty singularly focused on. But we have a different take, and I'll get into that in a little bit. The goal would be that that trip doesn't take an hour and a half every day, but maybe it can take just 15 minutes. And that's real value that cannot be accessed by any other technology right now that we can provide millions of people around the world. So, whoops, a duplicate slide. All right, so what is Joby? Joby is actually kind of three different pieces that we are all building out to bring this vision to be reality. We have an aircraft, obviously. We love showing pictures of our aircraft flying. We've done a lot of work, and the vast majority of the company is building toward the goal of certifying and bringing this aircraft into the service that we are also building. So we're taking a vertically integrated approach, both down into our supply chain and up to our customers. So we're building out the service that will deliver on-demand transportation so you can do that trip to San Francisco whenever you want in 15 minutes. But then at the foundation, we're building the bones, we're building the platform of a next generation aviation company, because all of these technologies that we're building and certifying are going to play a key role in the next revolution that's going to take over aviation in the next few decades. So let's talk about the aircraft. So this is our aircraft. This is a vertical takeoff and landing aircraft. It's designed to carry 4 passengers plus a pilot. It is piloted. We're going to the market with a pilot. Has 6 propellers that can tilt from facing up, take off like a helicopter, tilt forward, fly like an airplane. What this allows you to do is have the operational flexibility of a helicopter to fit into urban fabrics, to fit into environments, and then have the efficiency of an airplane, which lets you make electric propulsion work, which is an enabler for this whole new class of aircraft, as many of you know. It's not a helicopter, though, obviously. It has none of the drawbacks, particularly from an acoustic standpoint. So let's see if this slide works. This is a little test we did. This is actually about 3 years ago now, 3.5 years ago. We flew, this is on our YouTube channel, so if this doesn't work, you can put on some good headphones and listen to it. But this is a calibrated microphone we set up in a very remote location. We flew multiple airplanes at the same altitude, similar speeds, along with one of our prototype aircraft, just to kind of get some sense to viscerally show people who can't go out and see one of our aircraft fly and witness one of our test flights on a regular basis. So here we go. It's actually working good. And this is pretty much what it's like when you see this aircraft fly in person. So it's not just the magnitude of the noise, which is real. When in overflight at about 1,000, 1,200 feet, so maybe 300 meters, we're at 45 dB or less, so it's basically silent. But it's the character of the noise as well. We've worked really hard to make an airplane dominated by broadband noise, not by tonal noise. And what that does is it's a completely different psychoacoustic effect, where it doesn't have the same noticeableness of impulsive noise that is characteristic of most aircraft in this space. This doesn't come for free. I'll talk a little bit more about that later. It has to be designed in. So we did a demonstration flight a little over a year ago off of the Manhattan heliport in downtown Manhattan, the one that actually Skyports just won the concession, one of our partners both in the US and outside the US, to manage going forward. And actually as part of a mayoral press conference with Mayor Adams in New York City, where they announced that new concession, that new RFP, which resulted in the concession, and which then required electrification. So we actually had a lot of folks come out to see this and witness it, and the major thing that stood out, again, was the noise profile, because it's a big deal. And the reason why helicopter air taxis have not scaled in most every part of the world is that noise is a major, major factor. And people don't want, especially once people have enough political voice to have their opinion be heard, they don't want helicopters in their backyard, especially overflight, because it's just too loud. And this technology changes the equation on noise. We actually did tests with NASA as the first company to fly under the national campaign, again, back in 21. and to measure this and actually demonstrate this. So we actually, they set up a big array of microphones, the NASA team did. They actually had to bring in special government-approved lawnmowers to cut down the grass because the grass basically moving in the wind interfered with the measurements because it was very quiet, the noise and the sounds that we were trying to pick up. We then can build acoustic hemispheres, which are models that we can then put into other environments. This is a modeling that we did earlier or actually last year when we went to New York, where we are comparing the noise footprints of a Joby aircraft to a light helicopter of equivalent kind of capacity, basically. And it's really different. And then when you hear it in person, you realize it's really different. And this is one of the underappreciated aspects is that you also, with electric aircraft, turn them off. So when you land, you turn them off. There's no penalty for doing that. It's just like a normal thing to do. But if you go to New York and you take one of the tourist flights off of the downtown Manhattan heliport, or you take one of the blade flights between the West Side and JFK, for example, they hot load usually, because that's how you get efficiency, which means the thing makes noise all the time. So there's a lot of really interesting kind of non-linearities in the way all electric aircraft in this air taxi mission are going to operate, which is why it's such an exciting market to be in. So again, kind of the basic specifications of the aircraft, targeting up to 100 miles of range for these missions, up to 200 miles an hour, our target payload, 4 passengers plus a pilot, so roughly 1,000 pounds. And again, like I mentioned, 45 dB in overhead flight at 100 meters and takeoff and landing, we're at 65 dB. So again, these things blend into the background noise, particularly when you take into account the character of that noise as well. And we're focusing on this air taxi mission. So we're designing the cabin specifically for the air taxi mission. It'll look a little different than this, a little bit of an old picture, but it's exciting to be able to think about that building an aircraft, designing an aircraft with a single mission in mind that's enabled by this new technology. And we've been really excited to show this to the world in a couple different contexts. We were in Grand Central Terminal a few months ago, as well as down in LA where we showed it off to the public. Let's talk a little bit about how we're going to actually deliver this to the world. So we're building this service. So fundamentally, it's going to feel very similar to hailing an Uber today. In fact, it might feel very similar because one of our partners, key partners for going to market is Uber, and will be available in the Uber app as well as in our own app that we're building out. So effectively, you're going to request a trip. You're going to ride to the vertiport. We're going to pool you effectively, fill seats dynamically in real time, more on that in a little bit, so that we can drive efficiency in the overall operation of these air taxis, fly to the remote landing location, get out hopefully as close to the terminal as you can, and board your flight on a partner like Delta, which is our key airline partner in the US, get to where you're going faster and better than you can any other way. So how does this work? So the reality is that there's a lot of trips going on, and we take a lot of time and energy to model this and look at data in a very fundamental first principles way. So this is data of trips across all of Manhattan kind of throughout a day, something like 29 million trips per day. Of these trips, the vast majority of them are pretty short, so under 50 miles, 80 kilometers as I have on this slide. So the vast majority of them are well within the capabilities of the range, and in fact, most of them are even much shorter than that, but still accessible to what we want to do. And so we can take that data and we can start to build out networks. We can start to look at how do you build a Skyport network based on the data of where people are moving today. Obviously, there's going to be latent demand as well, very hard to model up front, so we have to take that into account as possible future, likely, I think, in a lot of ways, future demand plus-ups in some sense to these kind of very fundamentals-based networks that we model. So you can take like a place like Manhattan and say, where do people want to go based on the data for these trips that could save time with a Joby aircraft, that have a price elasticity curve associated with it based on some other modeling that we do. And lo and behold, JFK is the first thing that comes up, which is not surprising, which also is a nice validation that our modeling makes sense. And you can just keep doing this cycle, though. So you can think about building these heat maps that then say, okay, well, where's the next place we should look? Where's the next place we should look? What's the next most efficient dollar to invest to put another node into this network? So we build a bunch of these models, and this is just an example with a bunch of parameters that you can tune and kind of based on different assumptions that you want to put into it or not. The nice thing is that this type of pattern, this type of behavior of the market is true not just in New York City, but in other markets. Los Angeles is a very similar pattern. Seoul, a very similar pattern. So we see a lot of potential. We can take these tools, we're deploying them in other places, we're looking at Dubai, we're looking at other markets that are very interesting in this space, that this tool set we're developing, which is very much based on the work that I did at Uber with Elevate that we brought over to Joby in the acquisition a few years ago, that helps us to really understand this. And then, how do you actualize it though? So to do that, we've built what we call Elevate OS. So it's taken what I did at Uber Elevate, and we've distilled it into software, which makes it scalable, which makes it something that we can deploy in different ways. So we've taken all the learnings, we ran Uber Copter, which was like the world's first really truly integrated into a rideshare platform, on demand, by the seat type of a service. And we've now built the fundamentals of this, coupled with the Part 135 certificate that we got a couple years ago at Joby, and that our Elevate OS is now actually the system of record for our Part 135. We've gotten the authorization from the FAA to use it in that way, and now we're continuing to develop it to then make this the foundation of how we bring this service to market. And then kind of the front of this, obviously, is going to be an app where you can do this on-demand booking in a way that is seamless and then integrates seamlessly with our partners, either Uber in us or us in Uber, depending on where you come in and what the entry point looks like, and more to come on the Delta integration down the road. And fundamentally, what this then lets us do, having this operating system, these apps that can integrate into different platforms, is access this pool of demand. So Uber has lots and lots and lots of eyeballs at any moment, which is the foundational idea behind Elevate in the first place, that are trying to go somewhere. If you can access those people, identify them, pool them together, that want to take an air taxi trip, you can then drive efficiency, and you can fill seats, and you can solve deadhead problems, and everything that has been the problem with kind of sparse networks goes away. So this is kind of one of the fundamental critical points of integration that we do a lot of work on, and we're really excited to have such amazing partners like Uber and Delta to help fuel that density of network to make this whole thing possible. And as you build out the network and as you fuel it by density, it's a nodal network. So every new node you add connects in kind of a nonlinear way, right? It connects to all the other nodes. So you get kind of exponential growth and like the ability of people to connect without having exponential cost increase on the linear road network, which is typical of a ground network. And then as you think about capabilities of aircraft increasing, which I'll talk a little bit more about at the end of this talk, you can start to think about larger networks that can basically extend and take advantage of the investments made early on in the smaller range networks and build on top of that, and then take advantage of the overall movement in the network, again, to minimize the deadhead problem. So as we think about this, one of the critical factors, though, is to have really smart approach on infrastructure. So we have some folks on our team that have experience at building crazy things like launch towers for SpaceX and other very focused and efficient approaches to bringing things to market. And so we're looking at ways we can build lightweight, deployable infrastructure that we can move pretty fast on. So we don't want this to turn into, even though nodal networks are efficient, you still have to put in infrastructure at all the different places. So you have to think about infrastructure as something that can be lightweight and deployable, more like putting up cell phone towers as opposed to building Taj Mahals. And so that's a really, really important piece of this. And we've done a bunch of work to think about how do these types of infrastructure ideas integrate in a very minimalist way into things like parking lots or parks or water, kind of like waterway type of locations in different places around the world. And of course, the canonical parking garage, which really is a very good option in many cases, as long as you're very smart about how do you put in these vertiports and how do you design them to be lightweight, integrated, and not a massive construction project. So wrapping up here, all of this is things that we're building on a foundation of a next generation aviation company that's powered by software that we are building at Joby. So like I mentioned, we're taking a vertically integrated approach. So this is one of our EPUs with a propeller on it. We build everything in here. We design, build, test, certify all of the environmental quals. If you come to one of our facilities, we show you the HERF chamber where we blast it with EM radiation, right? So we do all of this work because we think that this is the right way to bring this to market and build the foundational pieces that are going to be really, really important down the road. But it also lets us go pretty fast because inevitably you learn things. You have to pivot along the way. Hopefully not too big of a pivot, but little pivots as you learn things when you design, build, and test. And so we try to reduce that loop as much as humanly possible by the way we've built our engineering culture. And so, for example, this up here on the right, I guess, is the giant test track. It's like a 300-meter diameter, basically like flat roller coaster that we can run with like tethered power, one of our EPUs through the full dynamic range of both tilting motion and air speeds, and do it over and over and over again to do endurance testing in a way that's like very difficult, frankly, to do otherwise. And you don't have to have the 8x margins of safety for this, like you do in a wind tunnel, because we control the test environment, and so we can learn really, really fast on things like this, which is pretty important. This extends to other things that we've done. We actually released this kind of open specification around charging that we've designed to, like, again, be very, very integrated and focused on the air taxi mission. You have to charge fast and we think you have to charge fast in the loading and unloading phase of what you're doing when you're operating this at cadence in order to kind of drive efficiency in the network. So we've designed a system that integrates multiple independent channels of charging with cooling all into a single system that's like connected intelligently together, so the charging knows about the cooling, that allows no data to be uploaded to the aircraft but can ingest the data off the aircraft at high data rates every time you plug it in. We've opened this up. We're working with SAE and others to bring it as a standard, and we are excited to be talking to like many people in the industry about this, but we believe a air taxi focused charging approach is the right way to bring this aircraft to market, to make this market work. A little bit on batteries, I'll just skip over this, because I want to talk a little bit about some of the next generation innovations that we're making. So we did a demonstration earlier this year of a hydrogen electric demonstrator. And we acquired X-Wing, one of the leaders in kind of like the next generation of autonomy applied to aviation. We think these are two really important trends that fit into the longer range picture of what aviation becomes over time. And so I actually like to think about what we're doing really within, this conference is called Revolution, right? So everyone should be thinking about disruptive innovation. And what does that mean? And how does it apply in the context of aviation and aerospace? So let's just review, what does that mean? What is this concept of disruption that's talked about a lot in Silicon Valley? But what does it actually mean in the kind of the analysis of this? Well, if you think about kind of a very big simplification of this, and you look at some kind of a plot of performance of some key metric, so let's just think of it as range, typical metric of performance for an aircraft that is in the kind of traditional sense. And how does that metric of performance change over time? So you might say that, like, okay, customers have some expectation of performance on that metric, and maybe it changes a little bit over time, but there's kind of like some minimum bar for the typical things people use these aircraft and technology for. And then the incumbent technology, at some point in the past, because it's the incumbent tech, has like crossed the boundary of that customer expectation. And then it continues to get better, but like, how does the rate of improvement, it doesn't really matter to customers. I mean, think of like the next iPhone that comes out, right? It's got a new button, it's a little bit faster. Most people, the rate of replacement of their phones has dropped over time as effectively it's good enough. The incumbent technology is good enough, and the rate of increase is relatively small compared to what it was like in the early days when there's a truly new kind of cascade happening in the technology change. But if there's a new market that the incumbent technology can't access, then the customer expectation actually might be kind of low, or the new market might have a different demand on that metric of performance that is kind of irrelevant to that traditional technology. So in this case, like I was talking about New York, where like 99.5% of the trips that are accessible by air taxis are below 50 miles. You don't need 500 miles of range in order to do that. What you need is something quiet and something that's relatively cheap to operate, and that can't be done with incumbent technology. So then the idea of disruption, of course, is that this new technology can, of course, develop, some point cross that low boundary because it's opening up a new market, but then over time, it gets better at a faster rate than the old technology and eventually eats the original market too. So that's kind of the classic idea of how this works. I think in aviation, this is still true. It's just kind of drawn out because with certification and all of the very high bar of safety that we have to keep to bring commercial products to market, you kind of have to, it just takes longer. But as a result, you can kind of call your shots too, to some degree. And so our thesis is that the foundational pieces we're building, motors, the actuators, fly-by-wire systems, unified controls, all of the software and the machine to both build and certify all of this, are all of the key pieces on that disruptive technology that's necessary. And then as batteries get better, which they will, they get better every year. They're over double as good when I started working on this from 10 years ago, 15 years ago, actually. And then other things like hydrogen come into play. You start to see new capabilities coming to reality that you couldn't see otherwise when you just were looking at that first generation of new technology that comes in. Today, everyone has SSDs in their computers, right? Classic example, it's actually literally the classic example from a storage standpoint of that disrupting of waves of technology happening. Yeah, of course that's what you think eventually happens anyway. So we did this hydrogen electric flight earlier this year just to show a glimpse of what we think the platform of the next generation of aviation shows. And so we did, it was something like, it'll say here, over 500 miles, flew in circles. This is the actual ADS-B track of, or the GPS track of what we were flying down at our facility down in Marina. But this is the same airplane that we did a lot of other testing with. It's an older prototype. We just took some seats out, put an hydrogen tank in. It's not a product. It's not well integrated. But it's a glimpse of where it's kind of in some sense calling the shot on where this technology is going and why it's so exciting when you start to build a new foundation now of a totally different set of technologies that are well integrated that actually can then lead to a zero emission type of aviation that's not just sustainable, but it's actually better in a lot of ways. So, just to wrap up here, we recently announced a great new partnership with Toyota. Toyota is one of our key investors, our key investor and key industrialization partner. They came into our company early, led our Series C, and we just announced a new $500 million investment from Toyota a couple months ago that will come in a couple tranches. That we're really excited to take that partnership to the next level and really continue to deepen it as they are not just investors, but they're true partners. And frankly, one of the greatest manufacturing companies that's ever existed that's helping us bring this to market in the right way. We took one of our aircraft over to Japan a month ago, flew it in front of Mount Fuji. It was pretty exciting to see all of the key Toyota executives who are involved with this. Got to see it in person, and got to see it for real, and that was a great opportunity. This is just a little video. I'm just going to skip this. You can see this online. This is just a little bit, just to kind of illustrate a little bit of the relationship that we have. This is Akio Toyoda, who is the chairman of Toyota, from the Toyota family. He took Joe Ben drifting in the fog, in the rain, on the test track where we were flying and doing this demonstration. And I think there's going to be, at some point down the road, a video of this with some really great audio associated as they're swinging around. So, but this is just an example of how deeply connected we are to a world-class partner that we're working shoulder to shoulder with to make this real. And then look for us showing up in the near future as we participate in the KUM Grand Challenge in Korea, just kind of next door to where we were flying in Japan. So, in conclusion, this is what so many of us experience on a daily basis. This is also why so many of us are here. Let's make it real. Thank you. All right, I think there's time for a couple questions. Yeah, so first one, without IFR capabilities, how will you ensure on-time connectivity for passengers to scheduled airline flights? Thanks. So this is actually something that we did a bunch of testing with Ubercopter back in 2019 when we were flying that service. And there certainly is somewhat of a hit to your service availability, basically, with only VFR, but it's day-night VFR, and it's actually not that big. So I don't remember the exact numbers, but it was actually, there's not that many days that you have to, that you can't fly because of inclement weather, like real icing conditions. And in like a market like New York, that's the primary thing that would keep you from flying. All of those helicopters operate VFR, day-night VFR, same way. We also think that there's a lot of, I mean, we're creating, there'll be block upgrades, and so these capabilities will slot in, I think, relatively quickly as we get through the initial certification. But we've really tried to take the right kind of targeted approach of what is the MVP we need to bring to market to get this whole thing going, get it over the line, and stay really focused on that. So we're not trapped in like trying to perfect that last 10% out of the gate. All right. Yeah, so we've done a lot of piloted testing. And so, look for our updates as we kind of do more and more of this, and we show and kind of increase our capabilities overall. We did a bunch of testing with the FAA last year, actually, and most of this is all in the low-speed regime right now. We take a very measured approach on this. We have a lot of things we need to test, a lot of things we need to do, and so we take a very risk-adjusted approach in terms of what type of testing, when we do pilot testing, when we do unpiloted testing, so that we really can take advantage of technology that we have, that when people were developing airplanes 10, 15 years ago, it just wasn't possible. But it is possible now, and so we take every advantage of that, and we do a ton of testing that is testing for purpose, and really we don't do a lot of kind of demonstration testing at this point. And so we give updates. I'll just defer the second part of the question. We give updates on a quarterly basis. We just did one recently in terms of where we are in terms of our cert progress, and so look for us to continue to do that. We think it's really important that we're transparent on that, but we also follow the rules. So we'll go to the next one. Same thing on the, okay, Julie, flight costs. Yeah, so on the cost front, there's a lot of variables, obviously, but we do a lot of analysis on this too. Our target is that we're able to launch, we think, and it's been true, it's been very consistent for the last few years when we talk about this. We think we can launch at a kind of competitive pricing to Uber Black. I'm not saying we're going to price it there, but we think that we can launch rationally, competitively to Uber Black on a per-seat basis. We think that as we develop the network and build some scale in it, that we can then drive that cost down and kind of head toward UberX-like pricing on a per-seat basis. Again, that doesn't mean we're going to actually price it there, because that's going to depend on a bunch of different things in terms of our overall price-demand approach, supply-demand approach. Certainly, we're going to be very supply-constrained in the very early days of us launching, and we'll take that into account because we have to manage availability as much as we have to manage cost. So we don't plan at initial launch to land airside at airports. So we've had a lot of conversations with folks like Delta about this. We think that the right approach is to leverage the infrastructure, like the human and procedural infrastructure that's there right now. But we do think there's interesting opportunities for that down the road. I mean, I know that there's been a couple different attempts at doing this over time with different other kind of operators in the space. I'm actually really interested in exploring that at some point, but that is not our plan at launch. We plan to launch ground side with a smooth integration with the terminals. Yeah, so we're taking a number of different kind of approaches on infrastructure. We are looking at some infrastructure that we're doing ourselves. We're looking at partnering with some folks on infrastructure, both in the US and outside the US. An example of the kind of very strong partnership approach would be with Skyports in Dubai. So we announced an opportunity in Dubai, basically a deal in Dubai, back earlier this year, where we're going to be the air taxi provider once we launch, and then Skyports is the vertiport provider. I like to call them Skyports, but they're the Skyport provider for the takeoff and landing locations in all of Dubai. And so that's an example of us working really shoulder to shoulder, hand in hand with the partner to be able to get the right infrastructure in place. In other places, we're looking at kind of different types of partnerships. Maybe we'll partner with a building owner across a number of different sites in a city. Maybe we will do some of these as our own version, owned and operated. We're exploring a number of different varieties of that business model. Have a number of different efforts kind of well in play in that regard. Yeah, so how would you characterize the FAA readiness for engaging in certification process for H2? We're not really working on certification right now on that. So we are doing, it's a prototype, demonstrations, a lot of interest from folks across government in different contexts and agencies. We're keeping our work with FAA laser focused on bringing our aircraft to market with the type certificate for the all-electric air taxi that I've shown a bunch of videos of to get that done as fast as possible. We're not trying to have additional scope right now, which would be the wrong move given what we need to do to get this aircraft done and into market. But that's a future us problem, so we will certainly revisit it at some point. All right, thank you very much.